Good morning, students. Today we are going to see in chemistry the new chapter, that is carbonyl compounds and carboxylic acids. Okay, so first in this chapter we see about this carbonyl groups. Okay, so once we heard the word carbonyl, the two things that you must remember is the aldehydes and ketones. That is the aldehydes and the ketones. Okay, so aldehydes and ketones comes under this carbonyl groups. Okay, so in this lesson we are going to learn about aldehydes and ketones. Okay, so first we'll see about the introduction. So the general formula for this carbonyl group is C double bond O. So this is the general formula. Okay, C double bond O is the functional group you see in this carbonyl group. So this group will be present both in aldehydes and ketones. In case of aldehydes, this it will be attached to the C double bond O is the functional group, and here one R group will be attached. It may be an alkyl or it may be aromatic group, aliphatic group, anything it can be. The other will be the hydrogen in case of aldehydes. In case of ketones, the same C double bond O, but here two alkyl groups or two aryl groups will be attached. Okay, so this is the difference between aldehydes and ketones. In case of aldehydes, you have one hydrogen group and an alkyl group, or aromatic group or aliphatic group, aryl group, anything it can be, this R can be. Okay, but in case of ketones there is no hydrogen, both will be the aryl group or alkyl group. This will be aryl, this will be alkyl group, this will be aliphatic, this will be aromatic. So any group can be attached here. Understood? Now I hope you understood what is aldehydes and ketones, what is the general formula for aldehydes and ketones, right? So we'll learn in detail about these aldehydes and ketones in this chapter. Okay, so first we'll see about the introduction. So in this introduction they have given you about the functional group. That is, if the group contains carbonyl group is present, means this they have a C double bond group. Okay, so first from where we will get this carbonyl group, from where we get this aldehydes and ketones, means it is present in the plants and animals. So where it is present, the proteins and carbohydrates that we intake in, that is present in plants and animals, it is rich in carbonyl group. Okay, so the plants and animals, the proteins and carbohydrates present in plants and animals is rich in this carbonyl group. So okay, so this is the important source of carbonyl group. So next we are going to see two important applications of carbonyl group. First one, it plays an important role in metabolic process. So in our body, this metabolic process is carried out by this carbonyl groups. For example, they have given you pyridoxal. So this is an aldehyde group. So from where we get this is from the vitamin B. So whatever foodstuffs containing vitamin B we are taking, it contains this pyridoxal aldehyde. So what does that do? It acts as a coenzyme. So it acts as a coenzyme, and it helps in the metabolic process in our body. So this is the first point. The second point is, it is an important constituent. It is an important component. This carbonyl group is an important functional group which is used in the preparation of fabrics, plastics and drugs. For example, formaldehyde, this is a commonly known aldehyde group. Okay, so this formaldehyde, it is used in the preparation of bakelite. So where do we use this bakelite, ma? So we use this bakelite in the preparation of switchboards. So switches all we see in our board, in our home, right? So that switches all made up of this material only, that is bakelite. Second one, it is used in the preparation of paracetamol. So I hope you have heard many times the word paracetamol nowadays. You are hearing. So fever means we are taking paracetamol only, right? So this paracetamol medicine contains this carbonyl group. Okay, so these are the two important applications or uses of carbonyl group. They may ask you in a 2 mark, either they will ask you as application or uses. You have to write these two. First is, it plays an important role in the metabolic process. Second one, it contains the it is used in the preparation of fabrics, plastics and drugs. You have to write the examples also. Okay, understood? Okay. So next we are going to see about the nomenclature of aldehydes and ketones. So what do you mean by nomenclature? It is nothing but the way or a rule to name a compound. So how will you name an aldehyde compound or a ketone compound? So this we have learned already in hydroxy compounds, how to name an alcohol we have learned, right? So you would have understood that, then this you will find very easy. That I have explained you in your class itself. How will you name an aldehyde? An alcohol. The same applies here also, but in alcohol you use the suffix as ol, right? So here you have to use as al for aldehyde, and for ketone you have to use as on. So this is the two suffix you are going to use here. So this you used for alcohol. Now you should not use this. For aldehyde you should use al, and for ketone you should use one, own. Okay, you should not say one, it is own. Ketone. Okay, this is own. So first, so already we learnt, if it contains one carbon atom, if a compound contains one carbon atom, then you say it as meth, right? So if it contains one carbon atom, you say it as meth. One carbon means you say it as meth, and two carbon means you say it as eth, and three carbon means you say it as prop, four carbon means you say it as but, 5 means pent. So this goes on, right? Pent, hexa, then hepta. So this you have already learnt. And if it is alkane means it ends in ane. If alkene means it ends in ene. Alkyne means it ends in YNE. So these are basic things you would have learned in your 11th standard also, and I have taught you in this hydroxy lesson also this basic things. The same you are going to apply here also. How will you name? So first we'll see each and one example, then you will find easy. So first compound is HCHO. So this is a functional group. If you see CHO, it is an aldehyde group. So if you see CHO, you have to write it as Al. Okay, the suffix should be Al. Okay, the suffix should be Al. So how many carbons it contains, ma? It contains only one carbon, right? It contains only one carbon. If one carbon is present, what is the prefix you have to use? It is the if one carbon is present, then what is the root or the parent compound? It is meth, right? So meth. So since it is a single bond, you have to write ane. Okay, primary suffix is ane. So secondary suffix is the functional group. What is a functional group? Aldehyde. So it is Al. So if you join these all, you will get methanol. So what is the name of that? It is methanol. So methanol is IUPAC name, and commonly you call it as formaldehyde. Okay, so if you are comfortable with IUPAC name, I have taught you many times in the class itself how to write an IUPAC name. So if you are comfortable with IUPAC name, you can name it in IUPAC name itself. Okay, so if it contains only one carbon, so we say it as meth. Only single bond is there, so so it is a functional group is aldehyde. So you say it as al. Okay, so basic thing you have to remember is, if it is an aldehyde, it should end with Al, and if it is a ketone, it should end with ONE. Okay, so the first one is the methanol. Understood? So second you have to see for two carbon. If two carbon is present, what is the root word? You say it as eth, right? So eth, then you have a single bond, so ane, and you have an aldehyde group, so it is al. Okay, so eth and all, so it is ethanol. So the common name is acetaldehyde, the IUPAC name is ethanol. So the third one is, you have three carbon atoms, so prop, and you have a so you have a double bond here. So in this, if the carbon goes on extending the chain, you have to start numbering the carbon. So you have to number, either you can number from this side or this side, but from where the functional group is present, there only you have to give the first preference. Okay, so this side only the functional group is present, so I'll number from here itself. So it is 1, 1 2 3 carbon. So 3 carbon is present, so it is prop. Since a double bond is present, you should end with "ene", not "ane", it is "ene". See here, it is not "ane", it is "ene". And which carbon this double bond is present? 1 2 in the second carbon is present, so it is an aldehyde group which is present there. So prop 2 in all, right? I hope you understood how to name. Okay, if you are clear with hydroxy groups, then you will have a clear concept of this also. I hope you understood. Prep 2 enol. So the common name is acrolein. So they may ask you the common name and they may ask you to write the IUPAC name also. So these are some of the important IUPAC common names. So these all you have to remember. Next is the 4 carbon atoms. It is crotonaldehyde. So you have to see all these. Okay, so you see all these means it is but. Since it is 4 carbon atom, you say but. Second carbon, the double bond is present, so 2 ene, and it is aldehyde group, so all. Similarly for glyceraldehyde, so the common name is crotonaldehyde for this. So next is you have to see how much carbon is present. 1 2 3 carbon is present, and you have a functional group as aldehyde group, so Al. So 2 OH group is present, that is a substituent. It is a substituent. OH group here is a substituent. You should not take it as a functional group. Since it is present as branch, it is a substituent. The functional group is CH only. So 2 hydroxy groups are present in the 1 2 3, the second carbon and third carbon. So 2 3 dihydroxy propan, only single bond is there, no, propanol. So 2 3 dihydroxy propanol. Okay, the similar way, this is benzaldehyde. So it is a phenyl group which is attached there. So in the phenyl group, an aldehyde group is attached. So it is phenyl methanol. Okay, understood? Since only one carbon is present here, right? So it is a phenyl group. So one carbon is only present there. So it is phenyl methanol. Understood? So next one, you are going to, so till now we saw only aldehyde group. So now we are going to see about the ketone group. Okay, so ketone group means C double bond O. I said here hydrogen will not be present. The 2 will be an alkyl or 2 aryl group or aliphatic group or benzene group. Anything can be present. Okay. So now this is the carbonyl group. This is the carbonyl functional group. Here 2R will be present, I said, right? See here one is the, I said no, if for ketones both will be RR group. For aldehydes only one H and one R. So here ketones both R is present. So how much carbon is present? 1 2 3. So 3 means prop. Prop, single bond is there. So and, so a functional group is ketone. So one. So prop and one, propanone. So this is the name. This is the function, sorry, IUPAC name. So acetone is the common name. Okay, so second you have to see for another group. So you see here 2 carbon is present, so 1 2 3 carbon, already here 3 carbon is present, and sorry, 1 carbon, 2 carbon, 3 carbon, 4 carbon, and here 1 carbon you have to take it as 2 carbon is present, no, 1 carbon you have to take it as substituent. See how I have written CH3, C double bond, 1 CH3 as a substituent. Okay, so CH, so this is the original structure. If you write like this, you will get how much carbons? 1 2 3 4 5 carbons will be present. So one, where is the methyl group attached? 1 2 3 4. So 4 methyl pent. See 3, where the double bond is present here? 1 2 3, third carbon only. This, I think it is not clear. Okay, this is the clear structure. In that third carbon only, you see this third carbon only, 1 2 3, third carbon you see the double bond, so 3 into one. So second carbon the ketonic group is present, so 2 one. Third carbon the alkene group is, double bond is present, so 3 in. So 4 methyl pen 3 into one. Okay, so you have to listen and then you have to carefully, you have to number the carbon, then you have to name. Okay, so the common name is mesitol oxide. So similarly they have given you for compounds, you have to go through it. It is See here one phenyl group is present and here one methyl group is present. So the common name here one ketone group is there. So methyl M only now comes first. So methyl phenyl ketone is the common name. So here acetophenone. So this is an the common name is methyl phenyl ketone. So IUPAC name is one methyl group is present. It is present in the first carbon. Then one ketonic group is present. It is also present in the two carbon. One you have to take it as a functional group. So this is a functional group. Okay, so this you have to take it as a substituent. So one phenyl, it is eth. Two carbon means eth one one. Okay, so similarly you see for these three compounds. Okay, so next we are going to see about the structure of the functional group. So in naming this compound, if you have any difficulty or if you for these three, I am going to give you as a homework. So this and this and this you have to work it out. You try by yourself. If you have any doubt, you can ask me. Okay, I'll help you. Surely I'll help you, but you have to try and write the name. Okay, so now we are going to see about the next topic, that is structure of carbonyl group. Okay, so already we have seen the structure of OH group and the structure of the phenyl group. Everything we saw, ester group, all we saw. So now we are going to see of the structure of the carbonyl group. So the structure of the carbonyl group means, I said carbonyl group means what should come in your mind? Aldehydes and ketones must come into your mind. Okay, so the first thing you have to remember is the carbon which is present here. So this is the functional group, right? So this is the functional group. So in this, the carbon which is present here is the sp2 hybridized carbon. Okay, it is sp2 hybridized carbon. And in case of so in case of aldehydes, here one will be attached to one carbon group, other with a hydrogen group. But in case of ketone, both will be CH group. Both will be aryl group, no? So in case of aldehydes, it will be attached. C will be attached to double bond O. It will be attached to one carbon and there will be hydrogen. Here it may be aryl, alkyl, any group. In case of ketone, the C double bond O will be attached here to one carbonyl group, another to another carbon. Both will be aryl group, no? Okay, so this you understood, right? So this carbon which is present middle, it is sp2 hybridized carbon. Okay, so here the C double bond O is seen in both, no, this functional group. It is similar to that of the carbon double bond in alkene. So alkene also you have a double bond, but the double bond is between carbon and carbon. Here the double bond is between carbon and oxygen, but the double bond is similar to that of the carbon double bond seen in alkenes. Okay, now, so this is the structure of aldehydes and ketones. Okay, so now first it has a 3 sigma bonds. So first carbon, it is attached to an oxygen, and this side it will, in case of aldehydes, it will be attached to an carbon. In case of aldehydes, here it will be attached to one hydrogen. In case of ketone, it will be attached to one carbon. In case of ketones, it will be attached to two carbon atoms. In case of aldehyde, one carbon, one hydrogen. Okay, but the bond will be same, single bond only. Here one bond it will be attached to the oxygen. So it overlaps the so carbon has 4 orbitals, 4 valence electrons. So here one valence electron will be occupied by one carbon. It will share its electron with one carbon. Here also it will share one. And here with oxygen, here with 2 carbons in case of ketone, with 1 carbon and hydrogen in case of aldehyde, and 1 will be with oxygen. Okay, 3 will be involved in bonding. Since it is an linear overlap, they overlap in a straight way in a same plane. It is a sigma bond. So how will if it is overlapping in a linear way state to state, you form a sigma bond. But if it is overlapping in the sideways or in the lateral, then it forms a pi bond. Here it will be only a straight way, it will be a linear overlap, so sigma bond will be formed. But hydrogen carbon has one more valence bond, right? It is unhybridized p orbital. First three will be involved in sigma bonding and one will be remaining with unbonding. So that is referred as unhybridized p orbital. So where will it go? It goes and it comes as a it occupies at the top and the bottom of the carbon. Okay, go. So if this is a plane, it is a planar molecule. Since it is a planar molecule, the structure of this is a trigonal planar. How do you say it is a plane? It lies in a plane. If I draw a plane like this, then I can say, see, it lies in the plane itself. Here one carbon, here one carbon. But this, so here one sigma bond will be there, here sigma. The unhybridized p orbital, one will be occupied at the above, other will be occupied at the bottom. Similarly for oxygen also, right? Oxygen also, one will be occupied at the top, other will be occupied. But here oxygen, it involves in one will be involved in bonding with carbon, the other will be as a unhybridized p orbital. So more it has two unbonding pair of electrons which occupies the remaining two p orbitals. Okay, so now what happens? So this is a pi bond. These two overlaps laterally in a side way and they form a pi bond. So they both form a pi bond. So pi bond will be formed here. Okay, and this pi bond, how do they appear? They mix together and they form a pi cloud. Okay, so how do they form the pi cloud? It will be joined like this. See, carbon